Hello everyone, good evening. Yes, good evening. So we'll start our video. So in this class, we're going to solve 2020 linear algebra UPSC mathematics optional solution, right? Paper 1. So already we have completed 21, 22, 23 and 24. So already we have completed 4 year solutions. So if you haven't watched all those videos, so please watch that video and come back to this video, right? Because in those problems itself, I have discussed many concepts. So in this paper, again, we have 5 questions overall for 70 marks from linear algebra. So we'll start our first question. Everything will be every question will be similar, right? You just have to go through all 10 PYQs and then you have to have a very good conceptual understanding. Then you can easily get 60 to 70 marks in linear algebra, whatever they ask, right? Okay. So we'll start our first question. So what this question says is, suppose M2 of R, that is, let M2 of R be the vector space of all 2 by 2 real matrix and B is a 2 by 2 matrix given by 1 minus 1 minus 4 4. T is a linear transformation from M2 of R to M2 of R given by T of A is equal to BA. Then find the rank and nullity of T. So what we'll do is we will find the matrix of T associated with this linear transformation. For that matrix of T, we will find rank and nullity, right? Also find a matrix A which maps to null matrix. That is, we need to find the null space also. So first, what they have given is they have given that T is a map from M2 of R, M2 of R to M2 of R given by T of A is equal to T of A is equal to B times A, where B is the matrix given by 1 minus 1 minus 4 and plus 4. So what we'll do is we will find the matrix of T with respect to the standard basis. So first we will find matrix of T with respect to standard basis. So T of 1 0 0 0, right? So I'm finding matrix of T with respect to the standard basis. So T of 1 0 0 0 is equal to B times A. So what is B? B is 1 minus 1 minus 4 and plus 4 times A. So A is 1 0 0 0. So what you'll do is you just multiply the matrix. What you will have? So this will be 1 into 1 minus 1 0, 1 into 0 0 0. This will be minus 4 0. Now you have to express this matrix as a linear combination of basis vectors, right? So we have to express this as a linear combination of basis vector. So x1 times 1 0 0 0 plus x2 times 0 1 0 0 plus x3 times x3 times 0 0 1 0 plus x4 times 0 0 0 1. Now you just have to solve for x1 x2 x3 x4. That x1 x2 x3 x4 will be my first column, right? Will be my first column in my required matrix. Okay, now it is very easy to solve for x1 x2 x3 x4 if your basis is standard basis, right? Because when you add these four matrices, what you will have? You will have x1 x2 x3 x4. Yes or no? If you multiply x1 and if you add all these four, you will have x1 x2 x3 x4. So these two matrices are equal. That means what will be your x1? So x1 is equal to 1. You just have to equate these two matrices. So x1 is 1, x2 is 0, x3 is minus 4 and x4 is 0. So we have found the first column in our matrix associated with the linear transformation. That column is given by 1 0 minus 4 and 0. Now we will find matrix of T with respect to the basis, standard basis. Second vector is 0 1 0 0, right? So let basis be, let basis be, let us take a standard basis, right? Okay. Now we will find output vector for each elements of basis vector, and for that output vector, you express as a linear combination of basis vector, right? Okay. Now similarly, for second basis vector, it is 0 1 0 0. So T of A is B times A. So 1 minus 4 plus 4 times 0 1 0 0. This is equal to, this into this is 0. So this will be 1, will be 0, and this is minus 4. Now you have to express this as a linear combination of, let us say, some x5 times 1 0 0 0 plus x6 times 0 1 0 0 plus x7 times 0 0 1 0 plus x8 times 0 0 0 1. So you just have to solve for x5, x6, x7, x8. So you will have this to be equal to what? 0 and then 1 and then 0 and then minus 4, right? Because when you add these four matrix, you will have x1, x2, x3, x4. After equate this, you will get x1, x2, x3, x4. Now similarly, we will find p of 0 comma 0 comma 1 comma 0, right? So this is p of a is b times a. So b is 1 minus 1 minus 4 plus 4 times a. So 0 0 1 0. So this is equal to um, so 1 into 0 minus 1 into 1 is 0. 4 into 0 minus 4 into 0, 4 into 1, that is 0. Now you have to express this as a linear combination of basis vector. So let us call this as some x9 times 1 0 0 0 plus x10 times 0 1 0 0 plus x11 times 0 0 1 0 plus x12 times 0 0 0 1. Now solve for x1, x2, x3, x4. What do you will have? This will be equal to minus 1, this will be equal to 0, this will be equal to 4, and this will be equal to 0, right? Now the last one, which is 0 0 0 1, so which is equal to 1 minus 1 minus 4 plus 4 times 0 0 0 1. So t of a is equal to p times a. So this will be 0, 1 into 0, 1 into 0 minus 1 into minus 1, minus 4, this will be 0 0, minus 4 0, this will be plus 4. Now again you have to express this in the linear combination basis vector. Let's say some x13 times 1 0 0 0, x14 times 0 1 0 0 plus x15 times 0 0 1 0 plus x16 times 0 0 0 1. Again, if you solve for these four, you will get this to be equal to 0, this to be equal to minus 1, to be equal to 0, this to be equal to 4, right? See, I'm solving is very simple. You just have to add these. You will get x13, x14, x15, x16, and these two matrices are equal matrices. That is 0, minus 1, 0, 4, and this matrix are equal. That means equality of matrix. X13 has to be equal to 1, this plus 1. X13 has to be 0, x14 has to be minus 1, x15 has to be 0, x16 has to be 4. So we have found we have expressed our basis vector, that is we have expressed our output vector as a linear combination basis vector. Now therefore, what is the matrix of T with respect to the basis? The matrix of T with respect to the standard basis is given by, see, this x1, x2, x3, x4 will be my first column, and this x1, x2, x3, x4 will be my first column, and then x5, x6, x7, x8 will be my second column, right? You have to write that. So we will write this as 1 0 minus 4 0, 1 0 minus 4 0, and then 0 1 0 minus 4, 0 1 0 minus 4, and then third column is minus 1 0 4 0, minus 1 0 4 0, and then 0 minus 1 0 minus 1 0 4. This is the matrix of T with respect to the standard basis, right? See, you should always go with the general format. Simply you should not write this as column. If it is a standard basis, then it will work. If it is not a standard basis, means what you have to write in the first column? You have to write this combination x1, x2, x3, x4 as the first column. If it is a standard basis, then x1, x2, x3, x4 turns out to be this x1, x2, x3, x4. If not a standard basis, you have to solve this like this only, right? Okay. You always go by this method for finding this x1, x2, x3, x4. Okay, I already stressed the importance of this in previous PYQs also, right? Previous year solutions in that some videos. Okay, so this is a matrix of T with respect to the standard basis. Now what we'll do is we will find the rank and then we will find the nullity of T. So we have R3 is transformed to R3 plus 4 times R1. So multiply 4 and then you add. So this is equivalent to, so this is equivalent to 1 0 minus 1 0 0 1 0 minus 1. You multiply 4 and then you add. You multiply 4 and then you add. This entire row will become 0. Now this is 0 minus 4 0 plus 4, right? Now you have to make this element 0 with the help of this. I'm finding rank, right? Reducing to row echelon form. So R4 is transformed to R4 plus 4 times R2. R4 is transformed to R4 plus 4 times R2. Now this will be 1 0 minus 1 0 0 1 0 minus 1. This is already a 0 row. You multiply 4 and then you add. You multiply 4 and then you add. It will become 0 0 0 0. Right? Now you can see there are two non-zero rows. There are two non-zero rows. What is rank of the corresponding linear transformation is 2. If rank is 2, what will be the nullity? If rank is 2, if rank is 2, what is nullity? So we know that by rank nullity theorem, rank of t, rank of t plus nullity of t is always equal to the dimension of domain space. So rank of t is 2, nullity of t, dimension of M2 of R is 4. So therefore, nullity of t is given by, nullity of t is 2, right? So nullity of t is 2. Nullity of t is 2. Now we should also find the null space also, right? Because the first part is over. Find the rank and nullity of T. So rank is 2, nullity is also 2. Now we need to find a matrix A which maps to null matrix. That is, we need to find the null space, right? Because you collect all those matrix A that maps to 0 vector. That all those matrix A will be my null space of T. We will find the null space. From that null space, we can find first we'll find null space and then we'll talk. So what is null space of T? See here T is a map from M2 of R to M2 of R. T is a map from M2 of R to M2 of R. So what is null space actually? You collect all those matrix in M2 of R that maps to 0 matrix. That is, here 0 vector of M2 of R is 0 matrix 0 0 0 0. Here you collect all those matrix that maps to 0. This all those matrix you collect it in a single set. That set is called as what? Null space of T. So null space of T consists of all those A in M2 of R such that T of A is 0, right? Such that T of A is 0. So null space of T consists of all those matrix in M2 of R such that what is T of A? BA, right? B times A is equal to 0. B times A is equal to 0. Now we will find all those A. Let us take Let us take A to be some x1, x2, x3 and x4. Right? Let us take A to be some x1, x2, x3, x4. Now you collect all those matrix A such that BA is 0. So BA is equal to 0. So what is B? B is the matrix 1 minus 1 minus 4 and plus 4. 1 minus 4 plus 4 times x1, x2, x3, x4 is equal to 0 0 0 0, right? The 0 is the 0 vector of M2 of R. So this reduces to x1 minus x3 is equal to 0, x2 minus x4 is equal to 0, minus 4x1 plus 4x3 is equal to 0, and then we have minus 4x2 plus 4x4 is equal to 0. I'm just multiplying and equating to 0. x1 minus x3 0, x2 minus x4 0, minus 4x1 plus 4x3 0, minus 4x2 plus 4x4 is equal to 0. Now we will solve for x1, x2, x3, x4. This reduces to a system of homogeneous equations, right? So we'll solve this homogeneous system of linear equations. So we will find the augmented matrix. So we have 1, 0, minus 1, 0, 0, 1, 0, minus 1, minus 4, 0, 4, 0, 0, minus 4, 0, 4. This is our A matrix. And then we will form augmented matrix. Now you have to solve this homogeneous system of equations. This reduces to, see, this matrix is same as this matrix, right? That no. So if you make the transformation, this will be equivalent to 1, 0, minus 1, 0, 0, 1, 0, minus 1, and then we have 0, 0, 0, 0, 0, 0, 0, 0. Yes or no? You do the same operations. R3 is equal to R3 plus 4 R1. After that, you do this operation, you get the matrix. Now we can see this system reduces to row echelon form. It is in row echelon form, and you can see rank of A is 2. Rank of A is 2. So that means number of free variable. Number of free variable is 2. So we have two free variables. Uh, if you solve this as equations, you will have x1 minus x3 is equal to 0. x1 minus x3 is equal to 0. And then we have x2 minus x4 is equal to 0. Right? Now we have two number of free variable. Number of free variable is given by n minus rank of A. So n is the dimension of our vector space, which is dimension of vector space, which is 4, minus rank is 2. So we have two free variable. So let us assume x3 to be equal to k1, x4 to be equal to k2. If x3 is k1, if x3 is k1, this implies x1 is equal to x3 and x1 is also k1. If x2, if x4 is 2, x2 is same as x4, x4 is also equal to 2. So that means this implies if x3 is k1, x1 is also k1. If x4 is k2, x2 is also k2. So therefore, our matrix A, all those matrix A which maps to null space of T is of the form. So x1 is k1, x3 is k1, x2 is k2, and this is k2. These k1, k2 belongs to any real number. So that means I can see that I can span this null space of T with, if I take k1 common, we will have 1 0 1 0 plus k2, if I take common, we will have 0 0 1 1. So you can see these two vectors spans the null space of T. So there are two linearly independent vectors in our null space. So therefore dimension of null space is 2. That means nullity is 2. That we have already got here. This 2 tells you that in null space of T there are two linearly independent vectors. That vector is given by this. So null space of A consists of all these kinds of matrices. All these kinds of matrices, right? So for example, if you take k1 to be equal to 1, k2 to be equal to 2, if you can take anything, then our matrix A will be equal to what? 1, 1, 2, 2. You can see this will map to 0 vector. You can check it. What is T of A? T of A is equal to B times A. So what is T of 1, 2, 1, 1? B times A. What is B? B is 1 minus 1 minus 4 plus 4 times A. What is A? I'm just finding output vector for 1, 2, 1, 2. This will be equal to what? 1 minus 1, 2 minus 2, minus 4 plus 4 minus 8 plus 8. So you can see this maps to 0 vector. You can take any k1 k2, right? So A will, if your A is of this form, then all those matrix of this form will map to 0 vector, right? That is what they are asking. uh, Find a matrix A. They are asking only one matrix, but we have found infinitely many matrix. If you want to find one matrix, you just put some values for k1 k2. Find a matrix A which maps to a null matrix. Okay, so we'll move on to the next problem. Define a n cross n matrix as A is equal to identity matrix minus 2u u transpose, where u is a unit column vector. Examine if A is symmetric. Examine if A is orthogonal. Show that trace of A is n minus 2. Find a 3 by 3 matrix A when u is equal to 1 by 3, 2 by 3, and 2 by 3. See, here they have given that this u is there. I'll start from here. This u is a unit column vector. This u is a unit column vector. So that means u is given by 1 comma 0, right? Now what about u transpose? U transpose is given by 1 0. Now we will just infer when you multiply u into u transpose, what you will have? 1 0 1 0. So this equal to, so this row, this column, this row, this column, and then 0 0. So we'll get a 2 by 2 matrix, right? Because this is 2 row 1 column, this 1 row 2 column. So product will be a 2 by 2 matrix, that is given by 1 0 0 1. Now similarly, what you also infer is you just multiply u transpose into u. So u transpose is 1 0, u is 1 0 column. So if you multiply this, you will have 1 plus 0, which is equal to 1, right? See, this is 1 row 2 column. This is 2 row 1 column. So product will be a 1 cross 1. So it will be 1. Here it turns out to be 1. Okay. So what we infer is if u is a unit column, if u is a unit column vector, then u into u transpose is given by this 2 by 2 matrix, and u transpose into u is given by 1 if this u is a 2 by 2 matrix, right? But here define a n cross n define n cross n matrix A where u is a unit column vector. Okay, here they haven't mentioned. Okay, actually this is for u is unit column vector. This is for 2 by 2, right? This is for 2 by 2. Similarly, if your n cross n matrix, the unit column vector will be what? 1 0 0 0 0 0 up to n zeros. Yes or no? See, this is for unit. This is for 2 by 2. And similarly for 3 by 3 also, if u is equal to 1 0 0, right? Then u transpose will be 1 0 0. If you multiply u into u transpose, you will get 1 this row, this column. So 1 0 0 0 0 0 0 0 0. And when you multiply u transpose into u transpose into u, you will get 1. See, what we infer is if u is a unit column vector, what we infer is we infer if u is a unit column vector, if u is a unit column vector, then u into u transpose is always equal to 1. Yes, sorry. U transpose into u is always equal to 1. Yes or no? U transpose into u is always equal to 1 if u is a unit column vector. For 2 by 2 matrix, you can say it is 1. For 3 by 3 matrix also it is equal to 1. For n by n also, this will always be equal to 1. Right? Okay. So what we infer is if u is a unit column vector, u transpose into u is 1. For this only we have worked this. Now we'll move on to solving questions. We need to see whether this, what is a matrix A? Define a n cross, A is a n cross n matrix that A is given by I minus 2 into u transpose, right? This u is a unit column vector. We need to check whether if A is symmetric or not. So we will check, we will find A transpose. If A transpose is equal to A, we say A is symmetric. So we will find A transpose. So I minus 2 in U into U transpose whole transpose. So A plus B whole transpose is same as A transpose plus B transpose. So we will have I transpose minus 2 times U into U transpose whole transpose. I am bringing transpose separate individually. So I transpose is same as I. So 2 times U AB whole transpose is same as B transpose A transpose. So I minus 2 times U transpose transpose is U into U transpose, which is equal to A again. So we have started A transpose turns out to be A. So this implies A is a symmetric matrix. The A which you defined as I minus 2 into U transpose will be it is a symmetric matrix. Now we need to see whether is this A is orthogonal. When a matrix is orthogonal, A into A transpose is equal to ID matrix, right? So we will check whether A is orthogonal or not. A is orthogonal or not. We will check this. So first what we'll do is we will find A into A transpose, right? We already know this A is a symmetric matrix. That means I can write this A transpose as A again. So we need to multiply A into A. What is A? A is given by I minus 2U into U transpose. I minus 2U into U transpose. So this is I into I is I into I is I, and then minus 2U U transpose, and here minus 2U U transpose plus 4 times U into I minus U into U transpose. 4 into U into U transpose U into U transpose. Is it clear? I'm just multiplying all this, that's it. Okay. Now, so this is I times U into U transpose. U into U transpose is 4 times U into U transpose plus see. We know that this U transpose into U is 1. So can I merge this U transpose into U? Can I write this as 1? So we'll have 4 times U into U transpose. 4 times U into U transpose. Because we know that U transpose into U is equal to 1 if U is a unit column vector. These two will get cancelled. So we have proved that A into A transpose is equal to I. So therefore this A is orthogonal. Right? So therefore this A is orthogonal. Okay. Yes, this is symmetric. Yes, this is orthogonal. Show that trace of A is given by n minus 2. Okay. So we need to find trace of A. We need to put this equal to n minus 2. Now what is A? A is given by I minus 2 in U transpose. Now what is the trace of A? So it is trace of I minus 2 U transpose. So trace of I plus A is trace of I minus 2 times trace of U into U transpose. What is trace of identity matrix? It is equal to n. I is In. It is ID matrix of order n. So it will be equal for trace of I2 is 2. Trace of I3 is 3. So trace of In is n minus 2 times. Now what is trace of U into U transpose? We can see that U into U transpose always have 1 here and every element will be 0. You can check it out, right? You will have 1 here and all that will be 0. So also we infer that trace of U into U transpose is always equal to 1. So I can put it here that the trace of U into U transpose is always equal to 1. So therefore, trace of A is equal to n minus 2. You know what is trace, right? This is nothing but sum of the diagonal element. So we have proved the third thing, that trace of A is equal to n minus 2. So what is the fourth thing they have asked? They They have asked find a 3 by 3 matrix A when U is 1 by 3, 2 by 3, 2 by 3. U is given by 1 by 3, 2 by 3, 2 by 3. So we need to find a 3 by 3 matrix A. So what is A actually? A is given by I minus 2U U transpose. So I is given by 1 0 0 0 1 0 0 0 1 because this U is a 3 row matrix. So this is 2 times U. So U is 1 by 3, 2 by 3, 2 by 3 into U transpose 1 by 3, 2 by 3, 2 by 3. So this is equal to 1 0 0 0 1 0 0 0 1 minus 2 times. So this row, this column 1 by 9, this row, this column 1 by 9, 2 by 9, 2 by 9, this row, this column 2 by 9, 4 by 9, 4 by 9. Again, this is 2 by 9, 4 by 9, 4 by 9. Right. Now this is equal to what? 1 minus 2 by 9, 0 minus 4 by 9. So this is minus 4 by 9, 0 minus 4 by 9, minus 4 by 9. This is 0 minus 4 by 9. This is minus 4 by 9. This is 1 minus 8 by 9. 1 minus 8 by 9. This is minus 8 by 9. 0 minus 4 by 9. 0 minus 8 by 9. And then we will have 1 minus 8 by 9. So the matrix A is given by 7 by 9, minus 4 by 9, minus 4 by 9, minus 4 by 9, 9 minus 8, 1 by 9, minus 8 by 9. Then we have minus 4 by 9, minus 8 by 9, and 1 by 9. This is the matrix A if our U is equal to 1 by 3, 2 by 3, and 2 by 3. Yes. Very simple problem. See, this car is 20 marks, right? Not even will take 5 to 6 minutes to solve this. Since I'm teaching and solving, it may take time. But if you do this individually, very simple. Okay, so we'll move on to third problem. Let f be a subfield of complex number and a function f3 to f3 given by, we have a linear map t of x1, x2, x3 is given by this. What are the conditions on a comma b comma c such that a comma b comma c will be in null space of t? Okay, so we will find the null space of t, right? What is null space of t? So null space of t consists of all those ABC in our domain space, which is F3. See, F is any field, right? F3 such that you connect all those A comma B comma C such that T of A comma B comma C is equal to 0. Yes or no? You connect all those at mapping to 0 vector of F3. What is T of A comma B comma C? What is T of A comma B comma C? So that is, what is T of A comma B comma C? A plus B plus 3C, then T of x1, x2, x3 we know, right? 2A minus B minus 3A plus B minus C has to be a 0 vector of F3. Okay, so that this implies we need to find A comma B comma C, that A comma B comma C satisfies A plus B plus 3C is equal to 0, 2A minus B is equal to 0, minus 3A plus B minus C is equal to 0. So we need to solve for A comma B comma C, which is nothing but a homogeneous system of linear equation, right? Okay. So we will solve this homogeneous system of linear equation. So we will find the augmented matrix. So 1 1 3 0 2 minus 1 0 0 minus 3 1 minus 1 0, right? So we have reduced this to row echelon form. So R2 is transformed to R2 minus 2 times R1. R3 is transformed to R3 plus 3 times R1. So this is equivalent to 1130. So you multiply 2 and then you subtract. You multiply 2 and then you subtract. So minus 1 minus 2 will be minus 3. You multiply 2 and then you subtract. It will be minus 6. It will be minus 6, then 0. You multiply 3 and then you add. You multiply 3. You multiply 3 and then you add. You multiply 3 and then you add. You multiply 3 and then you add. If you multiply 3, it will be 9 minus 1 plus 9. So which is 8 and then 0. Right? Now R3 is transformed to 3 times R3. This will be 12 plus 4 times R2. So now we have to make this element as 0, right? Now we see that this reduces to 1 1 1 1 3 0 0 minus 3 minus 6 0. Then we have 0 0 0 0. Yes or no? You multiply 3 4, so both will be 24. Now we see that rank of this matrix is given by 2 and number of free variable is n minus rank of A. So n is the dimension of domain space, which is 3, minus rank of A is given by 2. So we have one free variable. If you transform this to equation again, we have A plus B plus 3C is equal to 0. We have A plus B plus 3C is equal to 0. If I divide by 3, this is same as what? Or if I divide by minus 3, it is same as B plus 2C is equal to 0, right? Okay, I'll write it as it is. Minus 3B minus 6C is equal to 0, right? So this is the condition on A comma B comma C. This is the condition on A comma B comma C. If your A comma B comma C satisfies these two conditions, then this A comma B comma C will be in null space of T. Right? So we will find null space of T. So let us take C to be some K. So because we have one free variable, so solve this. So from here we have, if I take minus 3 outside, we will have B plus 2C is equal to 0, right? So that means let us take B to be equal to, okay, no problem. So B is equal to minus 2C. So we have B is equal to minus 2C, which is minus 2 times K. So B is minus 2K. B is minus 2K. And then we have A is equal to minus B minus 3C. So minus B will be 2K minus 3K. So minus K. So your A comma B comma C, the solution that is given by A is minus K, A is minus K, B is minus 2K, the C is K. If I take some K outside, minus 1 comma minus 2 comma 1, and this K belongs to real number. So this is our null space of T. So this is our null space of T, right? So null space of T, if you multiply any K with this, all those kinds of vector will map to um, null space of T, right? So minus 1 comma minus 2 comma 1, you can check it out, right? You can multiply any K with this. Let us take minus 1 minus 2 1. Let us take minus 1 minus 2 and plus 1. So minus 1 minus 2 plus 1. So minus 1 minus 2 is minus 3. Minus 3 plus 3 is 0. Yes. 2 times x1. So it will be minus 2. minus 2 minus x2. So minus 2 plus 2, 0. Minus 3 times x1, it will be plus 3. Plus 3, 1. 1 minus 1, 0. Yes. So this will be your null space of T. So this consists of only one linearly independent vector. So that means dimension of null space. Nullity of T is 2. Sorry, 1. Nullity of T is 1. From here also you can say rank is 2. Rank is 2. That means nullity has to be equal to 1 because rank plus nullity is equal to 3. Nullity is equal to 1. Okay. So nullity of T is 1. Here they haven't asked you to find null space. They are asking you to find nullity of T. Nullity of T, from here itself you can find nullity of T. But okay, anyway, null space of T is this space spanned by only one vector, which is linear independent also, minus 1, minus 2, and plus 1. So it has only one linear independent vector. That is, therefore nullity of T is 1. So if nullity of T is 1, find the condition on A comma B comma C so that A comma B comma C will null space of T. This is the condition on A comma B comma C. This is the condition to be null space of T. So we move on to fourth problem. Very simple problem, right? Just 11th standard level problem. Let A is equal to 102, 2 minus 1, 3, 4, 1, 8. B is equal to minus 11, 2, 2. See, this carries 15 marks, right? I can't even imagine why they are asking this kinds of question 15 marks. Nothing. Okay. So find AB. So find the product A into B. So A into B. So A is 102, 2 minus 1, 3, 4, 1, 8. With B. B is minus 11, 2, 2, minus 4, 0, 1, 6, minus 1, minus 1. So this will be equal to what? So minus 11 plus 0 minus 2, right? Minus 11 plus 0 plus 12 plus 12, right? And then this with this. So 2 plus 0 minus 2, 2 plus 0 minus 2, and then 2 into minus 11, minus 22 plus 4 plus 18, 4 plus 0 minus 3, 4 minus 1 minus 3, minus 44 minus 4 plus 48, 4 twos are 8 plus 0 minus 8, 8 plus 1 minus 8. So you can see that our AB is equal to ID matrix, right? So which is equal to an ID matrix of order 3. Now second one is find determinant of A. So determinant of 1, 0, 2, 2 minus 1, 3, 4, 1, 8. So 1 times minus 8 minus 3 plus 2 times 2 plus 4. So minus 11, 4 plus 2 plus 12. So determinant of A is 1. And also we define determinant of B. So determinant of minus 11, 2, 2, minus 4, 0, 1, 6, minus 1, minus 1. So this is equal to what? This will be minus 11 times 0 plus 1 minus 2 times 4 minus 6 plus 2 times plus 4. We will have minus 11, 4 minus 6 is minus 2, minus 2 minus 2 is plus 4, and then we have 8. So again, this is also equal to 1. So determinant of A is also equal to 1. Determinant of B is also equal to 1. Right? Okay. The second thing is we need to um, solve the system of equations, right? Okay, so we'll do that. Now we'll just solve the system of equations. Solve x plus 2z is equal to 3, 2x minus y plus 3z is equal to 3, 4x plus y plus 8z is equal to 14. See, you can see this coefficient matrix is nothing but your A matrix. With this coefficient matrix 1, 0, 2, 2 minus 1, 3, 4, 1, 8. So we will solve this by matrix inversion method. So our corresponding x is given by what is the coefficient ax equal to b. That is 1, 0, 2, 2 minus 1, 3, 4, 1, 8 times x comma y comma z equal to output vector 3 comma 3 comma 14. So your x comma y comma z is given by see, for this matrix your determinant is not equal to 0. Yes or no? Because this matrix is your A matrix. So this matrix determinant is not equal to 0. Right? This 1, 0, 2, 2 minus 1, 3, 4, 1, 8 inverse times 3, 3, 14. I'm just applying matrix inversion method, right? I'm just taking this matrix to that side because inverse exists. So that's why I'm doing this. Actually, what is this matrix? This matrix is nothing but A inverse. A inverse into 3, 3, 14. You don't need to find inverse for this matrix because we know that uh, since AB is equal to ID matrix, the determinant of A is not equal to 0. So this implies A inverse exists, right? A inverse exists. And also determinant of B is also not equal to 0. That means B inverse is also exists. Okay. So you here you pre-multiply by A inverse. So A inverse AB is equal to A inverse. So that means your A inverse is nothing but B matrix. Your A inverse is nothing but B matrix. So instead of you don't need to find inverse for this, even if you find inverse for this matrix, 1 by determinant of A into adjoint of A, you'll be getting B matrix only. So that means A inverse into this nothing but B matrix. What is B matrix? Minus 11, 2, 2, minus 4, 0, 1, 6 minus 1 times 3, 3, 14. Right, 3, 3, 14. So this will be your x comma y comma z. So your x comma y comma z is given by so minus 33 plus 6 plus 28. So 34 minus 33. So we'll be getting x to be equal to 1. Right, we'll be getting x to be equal to 1. And then minus 12 plus 14 is 2. 18 minus 3 is 15. 15 minus 14 is 1. So your x comma y comma z is 1 comma 2 comma 1. Very simple, right? Okay, so we'll move on to the last problem. So this is 15 marks. Okay, we'll move on to the last problem. Consider the set V of all n cross n real magic square. Show that this set is a vector space, right? So the set is a vector space. Okay. So we'll prove this. You know the definition of vector space, right? I've already explained many times. So what is the first? If you want to do this, very simple. Just you write down the definition of vector space first. I'm not going to do this. I'm just going to give you an hint. So let B be any non-empty set. This B is any non-empty set and F be any field. What is the definition of vector space? What is the definition of the vector space? Let B be let B be any non-empty set. Let B be any non-empty set and let F be any field. Let F be any field. Then this B is said to be a vector space, right? Then this B is said to be a vector space over F. Then B is said to be a vector space over a field F. You have to define addition and scalar multiplication as follows. Over F, if your V with respect to plus is an abelian group, and then you have to merge this V, you have to merge this V and F. So you take some UV, the field, you take some alpha beta in the field. So alpha into U plus B is equal to alpha U plus alpha V, and then alpha plus beta U is equal to alpha U plus beta U, right? And then alpha beta into U is same as alpha into beta U. Alpha beta into U is same as alpha into beta U, and there exists a unit vector 1, unit vector. There exists a unit vector, that is unity. Sorry, unity in 1, that is 1 into U is equal to U. 1 into U is equal to U, where 1 is the unity of F. So if your V satisfies these 5 conditions, then we say this V is a vector space over F. For this V plus to be an abelian group, it has satisfy closure. That is, it has to satisfy closure, and then associative, and then existence of identity, existence of identity, and then existence of inverse, then commutative. Right, I'm assuming that everyone knows the definition of vector space. So if you haven't know, just go to my playlist of linear algebra. You will be seeing a vector space. See here, your V is nothing but your set of all magic square, right? So for example, can you tell me a 2 cross 2 magic square? You consider element U to be 2, 2, 2, 2. This is a magic square, right? Sum of rows, sum of columns, sum of diagonals, all are equal. Let us take V to be some 4, 4, 4, 4. All these element is of the form n cross n magic square. I have taken for example 2 cross 2 magic square. It is associated. So we have to tell that this set V is an abelian group first. I'm not going to tell. I'm just going to say. You write it down. You have to say that V is an abelian group. What is closure property? You take two elements in V, then you have to prove U plus V is also in V with respect to addition. So you take two elements in V. V consists of all those magic squares. What is U plus V? U plus V is 6, 6, 6, 6. Again, it is a magic square. So that means it satisfies the closure property, and also it will be associative also, right? That is U plus V plus W is same as U plus V plus W. And existence of identity. So what is it? What will be your identity element? 0, 0, 0, 0 is a magic square, right? This will be your ID element. This is also a magic square. If you add any magic square with this magic square, you'll be getting that magic square which you added. Yes or no? That is That is, if you add any magic square a with this magic square 0 0 0 0, you'll be getting a again. This is definition of identity, right? What is the definition of identity? A plus e is equal to a. So 0 0 0 is your identity element, and that belongs to B because it is a magic square. And what is the existence of inverse? So for every magic square a minus a minus a minus a minus a is your inverse. Is the inverse. Why? Because if you add this with this matrix, you'll be getting the ID element which is 0 0 0 0. So for every magic square A, I'm just explaining for 2 by 2 magic square. You can generalize for n by n magic square. So for every magic square A minus A minus A minus A minus A is the inverse, right? So again, the inverse exists, and this also belongs to V because this is also a magic square, right? And again, it is commutative. A plus B is equal to B plus A. So the set B is an abelian group with respect to addition. So we have said the first thing, and then these are very simple, right? You can prove all these property. You just take two magic square u and v. You find the sum u plus v. You just multiply alpha, find the sum, and then you multiply and then finding sum. See here, this u and v acts as a 2 by 2 matrix. So therefore, these all will be true. If your n is a 2 by 2 matrix, right? We can generalize for n by n matrix also. Okay. Consider the set V of all n cross n real magic square. Show that V is a vector space over R. Yes, our V with respect to plus is an abelian group. It is closed. It is associative. Identity element is 0 matrix is your identity element. And what is your inverse element for every matrix? That is, for if you take any A in A, minus A is the inverse, right? For example, if you consider A, your inverse is minus A minus A minus A minus A, because we add these two matrices, you'll be getting the identity element, which is 0 0 0 0. I'm assuming that, and if you don't know the definition of vector space, right? Okay. And then commutative, yes, and then it's so therefore the set V over a field F is a vector space. Give two examples of give examples of two distinct 2 cross 2 magic square. So you can see this is self and two distinct 2 cross 2 magic square. Right. So okay, so that's it. So we have completed this paper. So this carries 10 marks. So this carries 15 marks. So you'll have 25 marks. 25 marks plus 15. So 25 plus 15 is 40 marks. 40 marks plus 20 is 60. 60, and then the last first one that carries 10 marks. So we have 70 marks from 5 questions, right? So in the next video we will solve, we have completed 2020 paper. So the next class we will solve 2019 paper, right? So thank you, all the best.